Hey, what's going on, everybody? It's Derek here, and we're back for week 3, which is going to be the compute summary here, and it's also going to be storage. But to be honest with you guys, I kind of screwed up the first time I did this one. I had my head over here, which obviously cuts off a lot of the slides. So we're gonna redo it now, but when something is important, you do it right. Okay, that's hopefully the attitude you have about your exam. It's important, so you're gonna do what you need to do to make sure that we get that passing score on the first try. All right. So the compute summary, we have Amazon machine images. Okay, and AMIs are templates that are based on existing instances that you can use to quickly launch new instances. You've got a few different instance types, and essentially these instance types are defined by their values and properties, like memory, storage, network performance, things of that nature. Some instances actually don't support ephemeral storage, right? So that storage is physically attached to the instance. I've seen that as a test question, so important little tidbit there. But the instance types that you have available as of now are general purpose, which are used for just various broad use cases. Compute optimized, which are going to be used for compute heavy workloads like batch processing or maybe some scientific workloads. You've got memory optimized, which are used for processing data sets in memory, such as big data analytics. You've got accelerated computing, which is going to be used for very high performance compute workloads, such as machine learning. And finally, you've got storage optimized instances, which are going to use or be suited for workloads that have a high IOPS performance. Okay. So EC2 purchase options, you've got some flexibility here with how you pay for your compute. So you've got on-demand instances, which can be launched or terminated at any time, right? On demand, you pay as you go. And they're used for, irregular and perhaps interruptible workloads or even test workloads, like we said earlier. You've got spot instances, which are the largest cost savings by far, up to 90%. And they're best for workloads that can be interrupted because you just want to plan on your spot instances being reclaimed by AWS at some point. Reserved instances basically give you the choice to purchase instances for 1 or 3 years. You can pay using all, partial, or no upfront. More upfront is, of course, going to be a lower monthly payment, with obviously all upfront being no monthly payment. Scheduled instances, which are similar, but you basically just pay to reserve instances on a recurring basis. So maybe for between the hours of 5 and 8 p.m. Monday through Friday, for example. It's best for scheduled workloads, so maybe some kind of processing or whatever. And then capacity reservation, which allows you to reserve capacity for EC2 instances with specific attributes such as instance types that we looked at earlier, maybe platform or something else, okay? EC2 tenancy is essentially how your instance is located on AWS hardware. So you've got shared, which is the default, which means that you just share AWS servers and the underlying hardware with other EC2 customers, wherever. Dedicated instances, which are running your own instances on a single tenant hardware. So it's not necessarily an entire rack, but it's a piece of a rack, right? Some hardware on there that you're allowed to use and only you. And then you've got dedicated hosts, which is kind of an actual rack. It's a physical server that you can really customize as much as you want and configure it at will, okay? EC2 security. So remember that key pairs encrypt credentials to the instance, and then your public key is going to be what actually encrypts the data, and then the private key is going to decrypt it. We'll talk more about that in the encryption section. You can use the same key pair on multiple EC2 instances, okay? EC2 autoscaling allows you to automatically increase or decrease your EC2 instances to meet the demands of your application. Scaling up means increasing the size of an existing instance, otherwise known as scaling vertically. And then scaling out, or scaling horizontally, means adding more separate instances. Okay? Launch templates define the AMI, instance types, and other properties of a new instance when it is launched, so it helps you just kind of automate things even further. And auto-scaling groups let you define a minimum, desired, and maximum capacity of your instances. Okay? Elastic load balancing is essentially what allows you to control and route the flow of traffic that's coming into your applications or your network. It uses listeners, target groups, and rules. Okay? You can have an application, a network, or gateway load balancer. You can have targets that are EC2 instance fleets, Lambda functions, or even some containers. Okay? Lambda is the main service used to run serverless compute workloads. Okay, so Lambda is all about serverless. It uses what's called functions, which basically just are, like with programming, just pieces of code that do things to your AWS architecture and resources. And you only pay for the compute power used when your functions are run and for how long they run, but there is a limit to how long they can run. And then functions are triggered by supported event sources like S3, but there's plenty of others that it works with as well. Okay. All right, so let's get into storage. And this is definitely one of the longer sections here. So we will spend an appropriate amount of time on it to make sure that you know what you need to know. All right. So some of the key concepts with storage are that storage is different from database, and that with storage you have a little more flexibility on how the data you store is formatted. So, typically with a database, like a relational database, for example, you need data to be formatted in a certain way, so like with columns and rows. Or even if you're using like a NoSQL database like DynamoDB, right? You still kind of need to fit, some constraints, right? Because you need to have a primary key, right? Your partition or your sort key potentially. It can't just be anything, right? With something like S3, you could just upload it to S3, say, hey, here you go, hold on to this to me, and S3 is like, all right, cool, I'll have it for you when you need it. And some business requirements state that you need your data to be stored in a certain way, right? Maybe block data, file, or objects, and S3 can accommodate all that, right? You can also automate the uploads and removals of objects to your storage, and then you can save money by managing data and backups. Okay, so S3 is going to be our main sort of flagship storage service with AWS. It is object storage. We've got block storage, EBS, and then we've got file storage, EFS. And I said earlier that S3 can accommodate object, block, and file. Okay, that's not necessarily what it's best used for, but for example, you can store like EBS backups in S3. You can store like file backups in S3. You can kind of make like files of a sort in S3, right? And then you can have like a file and folder structure. But depending on the type of storage you need, your business requires, there's a service for it, is kind of the point here. All right, but S3 is designed to be object storage. It offers a virtually unlimited amounts of storage, and it is the most widely used AWS storage service. Okay? EBS is block storage, but it's really designed to work with EC2 instances because you can attach it to an instance, okay? And then Elastic File System is file storage. It's useful when multiple users need access to the same drive, so like folders and files, and it's designed to work with Linux, okay? AWS Snow family are physical devices that allow you to migrate data in or out of the AWS cloud. We'll talk about those a little bit, but those aren't going to really get, a deep dive necessarily like the other ones will, okay? All right, so S3, like I mentioned, it's a object-based storage service, essentially with unlimited storage capacity, right? It consists of objects, which are inside of buckets. All right. So an object is what actually contains your data. It's similar to a file. And an object consists primarily of key value pairs, kind of under the hood. That's how S3 works. And it could be all the way from 0 bytes to 5 terabytes in size, right? Each object. And again, I haven't seen this, but I've heard that AWS could potentially ask you, what is the size potential of an object? And if you see 0 bytes, then that is indeed an option, okay? So you also have buckets, which are what hold all these objects. And these buckets can contain folders to help you better organize your objects. A bucket name needs to be globally unique, so no other account anywhere in any region, anywhere in the world in AWS can have the same bucket name, all right? S3 is a regional service. However, you've got data that is replicated across multiple availability zones within the region that you're in, okay? So in S3, you've got a few different storage class options. And kind of the whole goal of storage classes is to help you kind of customize your costs and how much you pay to store your data. So you've got S3 standard. It is the default. It's the most expensive because it's extremely, it's got an extremely high level of availability and durability. It replicates across at least 3 availability zones, and it's a very, very fast data retrieval. Okay, you've got. I'm gonna skip over intelligent tiering for a second here. You've got S3 standard IA, which is infrequent access. And it's best for objects that are accessed less than once a month. It is cheaper than standard because your AWS and S3 aren't planning on you accessing this or these objects very frequently. But if you do need them, it's still very fast to retrieve that data. But just know that it's if you're regularly accessing things less than once a month, then you're going to pay a little extra for that. Okay. So intelligent tiering is not necessarily itself a storage class. It's more like a kind of S3 component that will use machine learning to move objects to the most appropriate storage class. So between like standard and standard IA, based on usage patterns, based on maybe your budgets, takes a few different factors into account. But it's an option to help you kind of automate things and automate your sort of cycling through storage classes, okay? You've got S3 a one zone IA, which is the same as standard IA, except it's only going to have your data in one availability zone. So it is cheaper, but it's also less durable. And then you've got S3 Glacier, which is going to be long-term storage for archives. It's very, very cheap, but data retrieval takes minutes to hours. And it uses what's called vaults and archives instead of buckets and folders. You have retrieval options that are either expedited, standard, or bulk. Okay, expedited is going to be a little more expensive, which is going to get you your data in less than 5 minutes, but it can really only be less than 250 megabytes of data. Right? You've got standard, which is the kind of first recommended use of this. It's going to take about 3 to 5 hours to get your data, which can be essentially any size that you need it to be. And you've got bulk, which is also recommended. It is 5 to 12 hours retrieval time, and it can do petabytes of data to you. All right. So typically Glacier is used for something maybe like reports or records that you need for auditing, but you only need them once a year. You could store them in Glacier. So you don't pay a lot for them over the course of that year. And then once you know that your audit is coming up next year or whatever, you can start to retrieve your data. Okay? And you've got S3 Glacier Deep Archive, which is the same as Glacier, but just cheap, slower retrieval times. So it's going to take at least 12 hours. All right? So S3 versioning. So these are all kind of different properties that you can put on a bucket that we're about to go through here. You've got actually, you know what? It's been about 15 minutes. Let's take a quick 5-minute break, and then we will come back and then pick it up with these bucket properties. Okay. welcome back. Let's get back into it. So, S3 versioning. So when you enable this, it allows you to have multiple versions of the same objects that exist, each having its own version ID. And once you enable it, you can't disable it. You can only suspend it to prevent further versioning. And it's useful for compliance requirements or to recover accidentally deleted objects. So, for example, if you had your original objects, you could have object v1, you could have object v2, object v3, so on and so forth. And if, say, your original object was deleted, you could restore it from version 1, 2, or 3, no problem. Okay, you could just start using a different version of that object. But because in that case, that's 4 objects being stored instead of just the one original one, you are going to pay for that. So keep that in mind, all right? S3 server access logging is going to capture details of requests made to a bucket and its object. Right? It gets most of the requests, but it's not guaranteed to get all of them if you've got a ton of requests coming in. And it's going to deliver logs to an S3 bucket for storage and analysis. It requires write access to a log delivery group in your target bucket ACL. Okay, so it just needs access to write to the log group. Okay. So S3 static website hosting is used for simple static websites that require really no server-side scripting at all. It's just like a really basic landing page. So for example, like maybe a menu at a restaurant, it's just like a 1 or 2 page menu, just a static page that just is what it is. Okay. It doesn't support HTTPS. The bucket and the contents need to be publicly accessible, right? Because if it's a website, then it needs to be accessible, all right? And to give you an example of what a sample endpoint would look like, you would have, http:// in this case, demo website .useast1-amazon.aws.com. So you would hit something similar to that, but it would obviously be more personalized to like your bucket name and things of that nature. Okay. And then as you can see here, you would want to specify like the index document for the home page of the website and maybe an error document. If you have like a custom error document you want to use, you could use redirect rules, things like that. So yeah, you have some options to host a static website on S3. So S3 object level logging is going to log specific API calls on S3 objects, and you can track things like get object, delete object, or put object. It's tightly integrated with CloudTrail since it tracks API calls, so you're going to need to utilize a trail in CloudTrail. Right? And then CloudTrail is going to capture events and then store those events in an S3 bucket for later use. Maybe you want to analyze them or whatever. So this would be an example of what some log output looks like as objects. So each of these is sort of a record from a log trail. Okay. Excuse me. And then again, if you had a ton of these, maybe hundreds or thousands or more of these, you could just use something like Athena to maybe analyze them. Otherwise, you can maybe look at individual records. If you're getting like a specific error and you're trying to figure it out, you could look there. But yeah, that is object level logging. Okay? Object locking is usually used for compliance requirements like Worm, so write once, read many. Basically, you don't want people changing your objects. Okay, if it's maybe something legally related, this could be helpful. You can only enable this on the initial creation of a bucket. So if you have an existing bucket, you can't really enable it. You have to create a bucket from scratch. And it also requires a versioning to be enabled. All right. You need to define which retention mode that you want to be used, whether it's governance or compliance. And there's really only one key difference here, okay? With governance, let's talk about what they both do first. So both of them prevent any user from doing a delete or an override on any object versions for the duration of the retention period, okay? That's what they both do. Now the key difference is that in governance mode, if you have the S3 bypass governance mode permission, which obviously only a very, very select few people should have that in the first place, you can override object versions or delete object versions, okay? But in compliance mode, you can't do that, and nobody can do anything, okay? So that's kind of the key difference there, and the compliance mode can't be changed ever, but with governance mode, if you have that specific permission, then you can potentially make some changes if required, okay? All right, so tagging is just like tagging with any other resource. It helps you to identify where your costs are coming from specifically, but you could also maybe tag if you had buckets for certain environments, like maybe you had buckets for production related storage or demo related storage or test related storage or different departments in the company, whatever. And then you could say, oh, is this part of website hosting? False, true, whatever. But essentially, these tags are also known as cost allocation tags. And, you could use something like Cost Explorer to work with these tags and see where your costs are actually coming from, right? It's very helpful if you have a lot of buckets, all right? Because you can see exactly where your costs are coming from and who's incurring what, all right? So, S3 transfer acceleration. This is going to be it's based around using CloudFront to dramatically increase the rate of data transfer over long distances to and from a bucket. So there is an extra cost to use transfer acceleration based on each gig of data that you transfer and which edge location you use. But say, for example, you had an S3 bucket in US East 1, but you needed to transfer data to Asia Pacific 1. You could use transfer acceleration to speed up that process, okay? S3 access control is what allows access to your buckets via policies, okay? And these can either be identity-based or they can be resource-based, right? And an identity-based policy is going to be attached to an IAM identity, and it can be associated with either a user, a group, or a role that a user can assume. But a resource policy is going to be attached to a resource rather than a specific identity. And in the case of S3, it's an access control list and or bucket policy that kind of determines that, right? But it's important to know that if you have similar policies, a deny will always take precedence over allow in your policies, okay? And that's just something AWS does to better help kind of protect their security measures, all right? So let's take a look at some example policies here. So on the left here, we have a policy that's a little more granular than over here. This one over here is an AWS managed policy that basically gives full access to S3. So, if you're working with S3, maybe you're an admin, you would want to do something like this. And what this one looks like is, so there's a version, I don't really ever change or mess with that. When you're making these policies from templates, which is generally what you'll do, you rarely start out with a policy from scratch. That's tedious and a lot of work. Why would you do that? But when you use a template, the version's always populated, so I don't really ever pay attention to that, honestly. But the statement is actually where you come in, okay? So in the case of this policy, what it's doing is it's allowing, okay, that's the effect. It's going to allow or deny. In this case, it's going to be an allow. And we now specify an action that is going to be allowed, okay? So in this case, we've got S3 actions. We can do anything. That's what this asterisk means, this wildcard. You can do anything, okay? And then the same principle here. You can do anything involving S3 objects in Lambda, okay? And then if you had a specific resource, like maybe a specific bucket, you would specify that here. But since this is S3 full access, this is just giving you access to all resources, all buckets, okay? So that is what this policy does, all right? It's very powerful, it's very broad, and obviously it shouldn't be given out lightly, okay? But over here, this policy has a little more to it, okay? So statement ID, I just said statement 1, but for being honest, you want to be a little more specific with your statement ID so you know what this is being used for. But essentially what this is saying now is that this policy, or this statement rather, in this policy is going to apply to a principal, which is a user or a resource. In this case, it's going to be coming from an AWS ARN, okay, which is going to be uniquely identified with my IAM user named Derek. Okay, so this would be like the account number, and then it would say user/Derek or user/whoever. All right, so that's saying that this statement is going to apply to this IAM user specifically. Okay, the effect is again allow. So this user Derek is now going to be allowed to do something. What that something is can be found in the action section here. All right, so you've got S3 delete object, S3 put object. Okay, you've also got a resource. All right, so it is again an ARN, and in this case it would be like a S3 bucket name. You would actually have the name of the bucket there. So again, to summarize this policy, it's going to allow this user from IAM named Derek to go into S3 and delete and put objects. Okay, but only in this bucket that's named S3 bucket name. Okay, so that is what this policy does. Those are a couple examples of policies. They're essentially just JSON documents, is what you'll most commonly see. So hopefully that's helpful. Having said that, though, it has been another. Actually, no, we got 5 more minutes. I think we can finish this up here. So again, identity policies are based around IAM. They allow you to essentially manage your access control methods all in one service. So for example, you could have like an IAM policy or an identity policy rather attached to a group, allowing them access to a bucket. You can use 1 to 2 policies across multiple buckets rather than, one bucket policy per bucket, so it's just a little less to manage. And it allows you to control access for more than one service at a time. Okay. Resource policies, otherwise known as bucket policies again, okay, because they work on the resource itself, the bucket. These allow you to have better control over a bucket and its objects, and it's going to maintain the security policies within S3 alone. Okay, so kind of multiple layers of security there. If you want to grant cross-account access without having to deal with assuming IAM roles, this would be the way to go. Right? So if you're working with multiple accounts and you need multiple accounts to have access to, a bucket or two, then start thinking about bucket policies. But if you want to control access for more than one, service at a time, so again, maybe you have a few services or resources in an IAM group, then use an identity policy. Okay? All right. So, bucket access control lists, ACLs. They control access to a bucket, so resource base, because we're working with a bucket, right? And specific objects within that bucket. Okay, you can have different permissions at the bucket and object level. So in other words, you can set different permissions for each object, but you can't use conditional access like you could with identity-based policies. So how I like to think of these is imagine you had a storage unit, and inside that storage unit you had a treasure chest. Okay, that storage unit is going to have one lock. Okay, so that's going to be like security at the bucket level, but then the treasure chest is going to have another lock on it, and that's going to be security at the object level. So in order to get to the treasure inside the chest, you need access to the bucket, and you also need access to the object. Okay, so that's kind of how I like to think of that. Hopefully it's a helpful analogy. But this is just kind of an example of what that looks like as you would see it in the console. So you could specify in this row here what the bucket owner, just your AWS account, what you can do on objects and the bucket itself. And same thing here, you could specify what would be for public access, authenticated users, and then log delivery groups. So that is ACLs, all right? So cross-origin resource sharing is going to be what allows specific resources on a web page to be requested from a domain different than its own, okay? So essentially, an S3 bucket is going to receive a request from a browser, and then it's going to evaluate the CORS policy on the bucket, and it will process the first matching rule. Okay? And a match is made when the following conditions are all met. Okay? The requester, so the entity outside of the S3 bucket, the requester origin header matches an entry made in the allowed origins element. Okay, right here. If we look at this CORS policy down here. The method used in the request is matched in the allowed methods element. So from trustedwebsite.com, it can only be a put, post, or delete method. Okay, and the headers used in the request need to match a value in the allowed header element. In this case, we're just saying any header. But this is essentially what it would look like. So if, for example, your S3 bucket had a domain, and you're hosting a status website, mytrustedwebsite.com, you could also allow trustedwebsite.com access. Okay, so that is essentially what a CORS policy is and what it looks like. Once again, it's just a JSON document. So if you're not familiar with JavaScript, maybe get a little bit familiar at least. Okay. All right, so now we are going to take that break, and then we'll come back and we will talk about lifecycle configurations. Okay, so take 5, and we will be right back. All right, let's get back to it here. So we've got S3 lifecycle configurations. So lifecycle configurations can be used to automatically transfer data to a lower cost storage tier, or to delete data after a specified amount of time because you're not using it and you don't want to pay for it anymore. Okay, so each lifecycle configuration consists of rules, and each rule has 4 components. You've got the ID, which identifies the lifecycle rule. You've got a filter, which is basically which objects in your bucket you want to actually take action on. You've got a status, which is just going to enable or disable each lifecycle rule. It's kind of good for testing if you want to see how it's actually going to work. And then actions define where you want to move your objects. So do you want to transition them to another storage class or expire them and get rid of them? Okay. So it's important to note that infrequent access and glacier tiers have a minimum amount of days objects need to be in them, otherwise you're charged for early retrieval. And you'll want to double check me on this, but I'm pretty sure for infrequent access, you need to have it for at least 30 days in there, and glacier, it's at least 365 days, okay? All right, so I know it feels like we've been on S3 for a while, because we have. It's a very important service. But now we're going to move on to EBS, Elastic Block Storage. So as the name implies, it's block storage. And it's designed to work with EC2 instances, as it can be directly accessed by the operating system of the instance. Okay, so it's kind of close to ephemeral storage, but it's going to be more persistent than ephemeral storage. It's primarily used for data that's rapidly changing, so maybe transactional. And if you need a specific IOPS rate, it can obviously have better IOPS and higher IOPS rather, because it's directly attached to an instance, and that's going to be very beneficial. Okay? You can attach EBS volumes to multiple instances, but only one at a time. I say that, but there's actually like one volume type now that came out a few months ago that can be attached to multiple instances. But for the most part, you can only attach to one EBS volume for to one instance. But you can take that volume off of that instance and put it on another instance. Okay, so it's kind of a one-to-one relationship, but you can swap out the volume, or which instance the volume is connected to, rather. Okay. So you've got 2 primary types of volumes. All right, you've got SSD based, which is or consists rather of general purpose and provision IOPS, and then HDD based, which is for throughput optimized and cold storage. Okay, so we got a chart here in a second. But the configuration of EBS. So I kind of alluded to this earlier, but your EBS volumes are very persistent, right? So if an instance that an EBS volume is attached to is stopped, restarted, or terminated, or otherwise has issues, the data on your EBS volume is still going to be there, unlike the ephemeral storage on your instance that will be lost, if you stop or terminate your instance. Okay? You can take backups of your volumes and encrypt them as well. The encryption is actually managed by AWS. You just have to enable it on your volumes. And every write to an EBS volume is replicated multiple times within an availability zone in your region. Okay, so it's very durable. You can resize your volumes with the AWS CLI, the command line interface, or by just making a snapshot of your volume and then creating a new, larger volume using that snapshot. Okay. As great as EBS is, there's a few scenarios when you may not want to use it. Excuse me. Again, for temporary storage, this isn't the solution. Maybe just use ephemeral storage. Okay. But if you want very high durability and availability of your data storage, consider using S3 and EFS. Not that EBS isn't highly durable and available. S3 and EFS are just more durable and available. Okay, so consider that. But if you're wanting to use storage that works hand in hand with EC2, then you definitely want to start considering EBS. Okay. So again, there's two types of EBS volumes that are currently available. You've got solid state drive, SSD, which is suited for work with smaller blocks or as boot volumes. Or you've got hard disk drive, which is designed for work with high throughput requirements, like big data analysis, for example. I'm not going to sit here and read off this whole chart, guys. That's just not really a good use of our time here. But you definitely want to get familiar with this, okay? Specifically, these four kind of categories, right? General purpose, provisioned IOPS, throughput optimized, and cold HDD. Because there's going to be times where you're asked about the best volume type to use based on workload requirements. So just get an idea of what the properties of each of these four types are. Probably don't need to know much about magnetic, otherwise, other than it's used for archives. So maybe don't prioritize that one as much. But SSD and HDD types you definitely want to get familiar with, okay? And here's kind of like a use case for each, all right? So EBS Multi-attach, I mentioned this is possible recently, but there's only two types of volumes that support this, and it's either IO2 or IO1, okay, which are both provisioned IOPS SSD volumes. A use case for this would be maybe workloads that require sustained IO performance or more than 16,000 IOPS, or IO-intensive database workloads. But you can only do this with EC2 instances that are based on Nitro system, which are also newer instance types, or instance qualities rather. So again, this is a very specific use case. You probably won't be using it much, but you know, it's I suppose it's helpful to at least know that it is possible and it's an option. Okay. So Data Lifecycle Manager. This is going to be a service that allows you to automate the creation, retention, and deletion of EBS snapshots. Okay. To fully take advantage of the automation component, right? To automating your architecture, your processes, right? Operational efficiency. You should be using tags on as much as you can, including your instances volumes and your backups, all right? And as you can see here, this is just kind of the available policy types that you have for your Data Lifecycle Manager policies. You can either do an EBS snapshot policy, which just automates, like I mentioned, the creation, retention, and deletion of EBS snapshots. Or you could do the same thing, but with AMIs, EBS-backed AMIs instead of the snapshots, okay? All right, EC2 Instance Storage. I've been referring to this as ephemeral storage. It's the same thing. It's designed to be temporary, but you know, the instance store volumes physically reside on your instance hosts, right? It's not recommended for critical data because when an instance is stopped or terminated, this data is gone, all right? You can reboot your instance though with this data intact, but again, if it's stopped or terminated or corrupted for whatever reason, that data is gone, all right? So if you need more persistent data, think about using EBS, all right? But, you know, it does have benefits. There's no additional storage cost. It's included in the cost of the instance. It's got a very high I/O speed, right? Because it's part of the instance itself. And it's ideal for caching and buffering rapidly changing temporary data, all right? But again, don't use it for data that needs to be persistent, and don't use it for data that needs to be accessed or shared by multiple entities or instances or whatever, all right? All right, Elastic File System, EFS. It is a regional file system designed to work with Linux that automatically grows or shrinks based on usage, and it can be accessed from multiple sources at once. Right? It's commonly EC2 instances, but it accesses these instances via mount points. We looked at this in the EFS lab, but it's designed for very high throughput and low latency. And similar to S3, it's got some different storage classes that you can use to manage your costs, all right? You've got the standard, which is regularly accessed files, most expensive, but you get it really fast. But you're charged on the monthly storage amount of your file system, okay? Standard IA is infrequently accessed files. Once again, IA, infrequent access. It's cheaper, but you're gonna pay for read and write operations, because again, it's not designed to be accessed frequently. All right. You've also got one zone, which is frequently accessed data that doesn't need high durability because it's just going to be one availability zone instead of multiple AZs like standard. And then again, the cheapest is going to be one zone IA, which is the lowest amount of durability for the least, frequently accessed files. But again, it is cheap, so if you're going for cheap, consider that. All right. And then this is just kind of a summary of each of the storage classes there. As you can see, the standard classes are going to replicate to at least 3 availability zones, while one zone does 1. They all have a high level of durability and availability, but it's important to know that there are different storage classes to work with when you're using a EFS file system. Okay. All right, so you've got a couple different performance modes that you can use with EFS based on business requirements. You've got a general purpose performance mode, which is used in most use cases. It just is designed to have low latency. You've also got max IO, which is virtually unlimited throughput in IOPS. It does have slightly higher latency, but again, it's really just designed for high IO workloads as opposed to general kind of file access and sharing workloads. Okay. You've also got some throughput modes. All right, 3 types to be exact. You've got bursting throughput, which is essentially just going to scale your throughput as your file system grows. You can earn credits in periods of low activity, and then those credits will later let you burst for higher than your baseline throughput limit. You've got provision throughput, which is recommended if you know you're going to have a high throughput requirement and your limit usage will exceed 80% regularly. Okay. You've got elastic throughput, which is similar to bursting in a sense, but EFS is automatically going to scale your throughput up or down based on workload activity as opposed to the size of your file system. Okay, but it's recommended for unpredictable workloads. All right. So EFS mounting, I alluded to this earlier. You can use the mount helper, for example, to mount your file systems to instances. And essentially what that would look like is you have, for example, 2 subnets, and each subnet has 1 instance. You could put a mount target on each subnet, and those mount targets point to a shared file system. And when those instances write to that file system via the mount targets, each instance, despite being in different subnets, can see changes made on that file system, right? So it synchronizes the changes. But EFS Mount Helper helps you to put that target on wherever you want it to go, usually subnets, and it will help you mount your file systems so that your instances can, have consistent records of changes across your file system, okay? It's going to write logs to varlog Amazon EFS. If you ever do have issues, you can go check there. And you can automatically connect your instance to EFS at startup. All right, if you, for example, launch a new instance in a subnet where there's already a mount target, you could automatically map it to there, and that will map it to your file system. Okay. So EFS Security is, of course, something we are going to want to consider. All right, because security is, sorry, I was checking over here. Security is priority number 0 for AWS, as they like to say. So with EFS, you have layers of security by utilizing both encryption and data validation. Right? You've also got flat pricing based on each gigabyte of data transferred. Just throw that out there. But you want to make sure that the permissions needed to create your file system are managed. Right? So you've got managed permissions here, as you can see by the name in front of it here. So for EFS, create file system, create mount target. And then for EC2, you want to be able to describe subnet, create network interface, describe network interfaces. So if you want to create and mount a file system, then you're going to need these permissions. Okay? You also need permissions to view EFS resources, query EC2 to display your VPCs, availability zones, and security groups, and enable KMS actions if you are using encryption. All right, so you've got a few things that you need to properly work with EFS. All right. Encryption. So many businesses are going to require encryption. We're going to talk about that in our encryption section in a few weeks. So it's important to understand how EFS supports it. You can utilize encryption at rest using KMS, and your KMS keys can be either AWS or customer managed, depending on how much control you want over your encryption keys. And you can also encrypt your EFS data in transit using the TLS protocol, but you're going to have to enable that on your mount helper when you mount that to your file system onto your instance. Okay? All right, so encryption is huge, and EFS definitely supports it. All right. AWS Datasync allows you to transfer data from on-prem file storage systems to EFS, S3, or FSx, or vice versa. It requires the Datasync agent to be installed on-prem that sits between your file system and AWS storage services rather. It's useful if you want to transfer data across different file systems in either the same AWS account or a different one even. Okay? It can be utilized to create replicas of your file system in a different region for disaster recovery purposes. Okay? Just in case something happens to an entire region, God forbid, you can have your file system replicated in another one to make sure that everything's intact. All right? All right, let's go ahead and take another break here. And when we get back, I do believe that we can finish up this section. So quick break, and we'll be back. All right, welcome back. Let's get into it here and try to finish up here because, with that Pomodoro technique, we're supposed to be taking a 15-minute break for the fourth one, but I feel like, we're pretty close to the end here. So let's keep it moving with Amazon FSx. So FSx is similar to EFS in that it's designed to be a file system, but it's designed for a few specific use cases, particularly those not involving Linux. So you've got FSx for Windows File Server, which is a Microsoft Windows native file system on AWS. Of course, it's built on top of Windows Server, as you might expect. It's got shared file storage, similar to a Windows kind of native file system. And it supports the SMB protocol, Window NTFS, AD integration, and, a distributed file system. This coffee's going to be death to me, but I won't give it up. I refuse. FSx for Lustre is designed for compute-intensive workloads like ML. Okay, it can process massive data sets, and it's used for extremely high throughput in IOPS, so it's less, for like a shared kind of file system and more for a compute-intensive workload. All right, so I've seen that on a test before, and it's definitely been an answer, so remember that. All right, so FSx pricing. For Windows, you're going to pay for the storage you consume each month, so the capacity. For throughput, you're going to pay for the throughput amount you configure for the file systems. And then for backups, you're going to pay to store backups based on gigabytes per month of storage. All right. FSx for Lustre is based on, again, capacity, so you only pay for the storage in gigabytes per month that you use. All right, that's about it. Unless you transfer data between regions, you're going to pay just standard data transfer fees. All right, so a little simpler pricing for Lustre there. Okay. AWS Storage Gateway provides a gateway between your on-prem data storage and S3 and Glacier. Okay. It can be a software or a hardware appliance at your data center. And there's three types of storage gateways. There's a file gateway, which involves storing files as objects in S3, and it caches files on-prem at your data centers. And then you have pricing that's standard S3 storage pricing, and data written is at 1 cent per gigabyte. Right? You've got volume gateways, which are, there's two options here, right? There could be either stored or cached volume gateways. Right? A stored volume gateway has your on-premise data center as the primary data source, and then it uses S3 for your backup data storage. Okay? A cached volume gateway has AWS as the primary storage, but it's going to cache frequently accessed data on-prem at your data center for use. Okay, so that's kind of the key difference there. Try your best to remember that because it's probably going to be on the test. And then again, data written here is 0.1 cent per gigabyte. Okay, you've also got a tape gateway which works with Glacier. It's really just for archival storage and supporting kind of tape storage and legacy storage. So that's that. But really remember file and volume gateway. Okay. So file designed to work with files, obviously, and file-based protocols. And volume gateway is either cached or stored. All right. AWS Backup is a service that allows you to manage and implement backups across various different AWS services. You can automate backups from on-prem to AWS by using Storage Gateway. And it allows you to centralize logging for all your backup operations. So you can kind of see, if you have multiple backups going on, maybe to multiple accounts or multiple sort of data centers, you can centralize all the logging to see what's going on, if something is going on that's not expected. It works based on policies, which basically determine the exact requirements that you are going to need for your backups. So things like the backup schedule and window. Are there any lifecycle rules that are going to be used? Which backup vaults are you going to use? Regional copies, if applicable, and of course tags. Okay. So the AWS Snow family are physical devices used to move data in and out of the AWS cloud or from the cloud to on-prem. Right? It's best used for large data transfers, and it's not really used very often unless we're talking migration. But an example would be if you had to transfer 1 petabyte of data over a 1 gigabyte per second line from on-prem to AWS. That's pretty high speed if you think about it. That would take about 104 days. Okay. Versus AWS sends you, a Snow device, which let's just say, that takes about a week, 7 days, and then it takes you about a week to load up your data, and then it takes like another week to like ship it and return it to AWS, and then it takes maybe another week to actually have AWS upload all that data into the cloud. Even then, that's still only 28 days, which is much shorter than 104 days. Okay. So AWS Snow Cone is the smallest of the family. It's got a cap at 8 terabytes of storage for HDD or 14 terabytes for SSD. It's very mobile and it has a backup battery. It's almost kind of like a briefcase. You've got AWS Snowball, which is not very mobile, but it's designed to kind of fit on one of your data center racks. You've got two options here. You've got Snowball Edge Storage Optimized, which again, for storage, you're going to be storing more, so up to 80 terabytes of HDD storage. And Compute Optimized, which supports up to 28 terabytes of SSD. Okay? And then you've got AWS Snowmobile, which is a literal semi-truck of storage. It supports up to 100 petabytes or more potentially. I've never seen this, but I want to because it looks pretty cool. But again, here is an overview of each of the Snow, let's call them family members. So, get familiar with these. You won't be likely asked too many details about this. Just know kind of the hierarchy of Snow Cone being the smallest, Snowmobile being the largest, and maybe like the storage sizes that each supports. Okay? All right. So, storage summary. Let's get through this here. All right. So, S3 is the primary object storage service with virtually unlimited storage capacity and 4 storage classes. All right? You've got standard storage, which is general purpose. It's used for regularly accessed data. Intelligent tiering, which is used when the frequency of access of the data is unknown. It's going to move your objects between other classes based on usage patterns, some other stuff. Standard infrequent access is used for data not accessed frequently, but it still has low latency access if you do need it. And then one zone infrequent access is the same as IA, but just one availability zone instead of 3. Okay. Amazon Glacier can be Glacier or Glacier Deep Archive. It's used for archive data, which is really not meant to be accessed often, more than once a year even. It's got different retrieval options, which vary in price and time and cost, and include expedited, which is 1 to 5 minute retrieval time, standard, which is 3 to 5 hours, or bulk, which is 5 to 12 hours. Okay? S3 lifecycle rules are one of the best ways to manage costs in S3, and it allows you an automatic method that moves data between storage classes, right? So between standard and IA and one zone IA, so on and so forth. S3 transfer acceleration is used in long distance S3 data transfers, and it uses edge locations to do that. S3 versioning allows for multiple versions of the same object in a bucket. You need to enable it on a bucket, and once enabled, it can't be disabled, it can only be suspended. You can easily recover versions of deleted files, but there are additional costs for each version of the objects you store. S3 security. You can have security at the bucket and the object level. So remember, that's storage unit and that treasure chest level. Okay? You can control access with resource-based and identity-based policies. Bucket policies require a principal that defines the identity or the user that has access. S3 ACLs let you control access to buckets and specific objects in a bucket. Okay? By default, all public access to a bucket is blocked. Not a bad idea. Cross-origin resource sharing, or CORS, allows specific resources from a different domain to access S3 resources. Right? You can have server-side encryption of files with either SSE S3, SSE KMS, or SSE C. Right? So server-side encryption S3 is S3 managed. SSE KMS is Key Management Service managed, or SSEC is customer managed. Okay. Elastic File System is a fully managed service designed to create shared file systems that have high scalability and low latency access. Right? You can have EFS standard or infrequent access classes. EFS Lifecycle Management automatically moves data between classes. It is similar to like the S3 intelligent tiering. You've got encryption on EFS, which can be enabled for data in transit and at rest. Encryption at rest is managed with KMS, and in transit it uses TLS. EFS performance modes can be general purpose, which is the defaults and the most common. Max IO, which offers virtually unlimited throughput and IOPS. And then you've got EFS throughput modes, which can be bursted throughput, which is the default, and the throughput grows as you store more. And then provision throughput can burst above your allocated amount as defined by your file system size. And then you've also got elastic throughput, which it looks like I didn't put on here. Let's see, let's actually go back real quick. Sorry about that, guys. I don't want to leave it hanging here. So elastic throughput is going to scale throughput up or down based on a workload activity as opposed to your file system size. Okay, I'll be sure to put that on there before this PowerPoint's actually released so that you have that when you're reading it on your own. So EBS, Elastic Block Storage, you can have SSD or HDD backed storage that is designed to work with EC2. Okay? EBS snapshots, you can take them automatically or manually at any time. These snapshots are stored in S3 and can be encrypted. Any snapshot from an encrypted volume will be encrypted. And of course, you can't create an unencrypted snapshot of an encrypted volume and vice versa. Okay, so it needs to be like to like. And then again, here's the kind of chart here for EBS volume types. Get familiar with that. Amazon FSx is a file system storage for specific use cases like Windows or Lustre. Again, whereas EFS is going to be more for like Linux. FSx for Windows is based on Windows Server, and it can be used as a shared file storage that supports all Windows features and protocols. FSx for Lustre is designed for compute-intensive workloads like ML, machine learning, and can handle massive data sets with sub-millisecond latencies. AWS Storage Gateway is used in hybrid setups to manage storing data. You can have file, volume, or tape gateways, and of course volume can be either stored or cached. Okay. File gateways store objects in S3, and you can mount these drives to a bucket. Cached volumes use S3 as your primary data source, and it caches data on-prem for you to use. Stored volumes use your on-prem data centers as a primary data source, and then it's just going to use S3 as a backup to that storage. Okay. Tapeways are meant for legacy stores. They're sent to Glacier. That's all they're for, just for archives. All right, so that's it. We made it to the end. Next week we got database, but good job making it through here. Like I said, this is one of the longest sections, so definitely do the labs, and as much as you can and you're willing to, read the documentation for like S3, EBS, EFS, kind of get into it a little bit, and definitely review this section. Maybe do this one twice this week, because it's kind of a beast. There's a lot to fit in here. But hopefully that's helpful. Again, do the labs, and we will see you in week 4, where we are going to review all this storage nonsense, and we're also going to get into databases. All right, so take care, and we'll see you next time.